Okay, so welcome everybody. Today we're talking about servos in pinball machines. How do they work, and especially how do you use them with the Mission Pinball framework? And generally, where can you use them in pinball? Where you should be careful, and yeah, how they are used in other machines or in existing machines, and also like a little bit how they technically work internally. But on a high level. So yeah, this will be like a 10 minutes presentation, and afterwards we will have a small demo about my setup here, which I just showed you. So without further ado, this is like the agenda for today. First we talk about servos in pinball, then like which controller hardware is out there, and especially what is supported in the Mission Pinball framework, then which servo types exist, basically two, and I will show you those. And then how does the wiring work in servos? It's easy, but nonetheless it's important. And then how does like the data format, like the low level data format on the wire look, and how does that work? And it's important to understand that for some settings you have to do an MPF and also in other tools later. And at the end, probably the largest part is like a demo of my setup here, and also about like all the MPF configs. We will look into my configs for the setup, and I will talk a little bit about that and will explain how that works. So let's start with servos and pinball. So in general, like if you look in the last like 30 years, you won't find that many servos in pinball machines. So like Stern doesn't, or at least I don't know any machine where Stern uses servos. So they use like a normal normal DC motor, and then some position switches for the positions they need. And the reason for that is that it's probably cheaper, I guess. But like it's also a lot more complex if you want to build that on your own. So servos, like they got one advantage: you do not need any position switches, and it's basically just one piece. So you put it to a controller, and the servo can go to any position you programmed it to go, and it will also keep the position, and that's good in a lot of ways. So like for example, if you animate a toy, which would be like the Premiere thing to do with like servos, that's cool because I don't know, a ball will hit your toy and it will be moved a little bit. The servo will move back. I will show that later. And you do not need any switches. So if you got a lot of positions for your toy, then that's also very cool. And that's very usable. And on the right, I've depicted a small like it's basically a mechanical part which you can buy at SparkFun for like $5. And there's basically two servos, one on the bottom and one in the middle, and this allows you like to move a toy in basically in any direction, right, in two dimensions with very little mechanical and electronical effort. And it's like, I guess that's something which might be useful in some toys. It's not that small, but it can be useful. Doing the same with like DC motors would be like a lot of effort. Another thing in pinball where this can be useful is like for kind of diverters. And the reason why this is not useful for like other mechanics, like I don't know, like a trapdoor or so, is that you do not want your servos to be directly hit by a ball. They will take damage eventually. So there are few machines which did that. Like America's Most Haunted from Spooky did that with like this door before the toy, and that seems to hold up. But other than that, there are like very few examples where you can directly hit a toy with a servo. So that's probably not the greatest idea. You do it like take a very sturdy servo. Another issue is like because the servo like keeps its position. You might get issues that the ball might be stuck, and the servo will actively push against the ball behind it, and it will never stop. So you have to account for that. It's possible with ball search and such things to get it unstuck, sure, but you just have to think a little bit about it so that the servo will not trap a ball too often. And the diverters, again, it's very useful that this will, like a servo will then keep the position, and especially if you want to build the diverters for multiple targets, a servo might be useful. And in my opinion, those are like the main use cases for servos in pinball machines. So there might be more, but that's at least what I've seen, and what I think is useful here. But I mean, if you got more ideas, just write it in the chat, please. So what controllers do we have? In the Mission Pinball framework, there are a few. Like the most advanced controller is probably the Pololu Maestro. It's the one which I also got in my setup here. It's currently wired up, so I cannot show it here. But it's a small controller with a lot of features for like only $20. So that's super nice, and it can control like 6 servos, but there's also one for 12 or I think 18 servos, and you can also chain those, so that can be unlimited servos basically, with very few money. Then there's like the PD LED from Multimorphic, which goes to the P3 Rock, and in case you're already using that, this board looks like this. It supports up to 12 servos, and I think for every servo you just lose one. You can control one light less, so that's nice. If you already got the multimorphic system, I would go with this. Then from Fast Pinball, they got like their node system, right? So they got the controller, the Fast Nano, and the Fast Nano then interfaces to certain node boards. For example, this one, that's like a 3208, I think. So it's 32 inputs, 8 outputs, 8 drivers, and then there's like those daughter boards, they're called, and those can then drive 6 additional servos. You will not lose any like inputs or so, but and it will go like on here. Okay. Looks like this, and yeah, now you can control 6 servos as well. So that's nice because you can put them on any node board basically. So if you already got the fast system, that might also be a good option to control servos. Yeah, like this. I think the latest version is not green anymore, so it's basically an earlier version what I got. So the newer servo boards look a little bit different, but the functionality is the same. Then very basic but effective is basically the Raspberry Pi. It's also like $25-30, and it can control, I don't know, probably 15 servos or something up this header. And you can interface, so either you can run MPF on the Raspberry Pi, that might be viable for some machines, or you can also interface it via Ethernet. And there's like a daemon which you can run on the Raspberry Pi to then use some inputs and outputs on the GPIOs and also control servos and stuff like that. So that might also be an option for if you, for example, run like OPP and need some more, I don't know, some more GPIOs, and you got Raspberry Pi for display anyway, it can also run servos. And finally, there's also like from Adafruit, got like this servo controller, like a 16-channel controller, which is originally a PWM chip on it, and it interfaces via I2C, and I got a lot like this $5 I2C to USB converter here, which I just soldered to this board, and that's, yeah, it's also inexpensive. You can also control this board from the P3 Rock. It has an I2C bus, or you could also interface it via the Raspberry Pi if you want. That's also supported from MPF. So yeah, that's another option for servos. If I just wanted a servo board, I would definitely go with a Pololu solution. It's super stressless, just works, and it supports anything you can imagine. So that's, in my opinion, the best board as a standalone solution, unless you already got something existing from faster Multimorphic. So then we got different servo types, right? So if we talk about servos, that's basically, it's a motor with a feedback, with some kind of feedback, so it knows where it is, and you give it a command to go to a certain location. There are like RC servos and industrial servos. So in the RC is like radio controlled. That's like for all this toy cars and planes and stuff. And that's the type of servo we are using here. So industrial servos are like usually very strong or very precise, or often even both, and also very, very expensive, and you need very expensive controllers. So you probably can use them as well, but that's not something MPF currently supports, or we do not support any controller which controls industrial servos. So we focus on RC servos, and there's like a lot of them on the market. So like, I don't know, thousands of models, and that generally two types. And the one is like the tower servo type. That's the one on the picture on the right, which just turns around. And then there's like a linear servos, so like this one. It's like it can go out. I will show it later, and it can basically linearly move stuff in and out, and it's pretty strong. So like it's like a few kilograms, but it's not very. This one especially is not very fast, but you will see later. So this basically is the two types. And then for the tower servos, there's also standard or continuous servos. Like the standard servo is like, it's a standard thing where you can say go to position 180 degree, and it just moves to 180 degree, and then to 90, 180, 90, 180. And continuous is basically a little bit like a hacked servo where you broke the feedback, and it always gives the same feedback. And that allows the servo to turn around continuously, and you can control like the direction and the speed. So that's like you kind of can abuse it as a motor in this way, with like really, really good control. Then you need to like understand that there are like three types of those tower servos. It's micro, standard, and giant. Those are more or less standardized sizes. So the one on my picture here is like a micro, and I also will use that one later. That's often used on RC planes. It's like 9 grams, I think. It's really light. So the larger ones are larger and more powerful. So they can drive more mass. And you can also get like them with plastic and metal, and there are literally thousands of options depending on your budget and size, or your space and your financial budget. So you can choose out of a lot of servos. But there are like still those three like categories for the size. And there's stuff out of that, but that's the most common, probably like 95% of the available stuff. So how do you wire it? So usually you got like your PC with MPF, and then you interface a controller via USB. As I told you earlier, for the Raspberry Pi, you can also use the native, that's native. You use the GPIO on the Raspberry Pi directly and run MPF on the same thing. So this would be one, but in most cases there's some kind of controller, right? And then servos get like 5 volts from a power supply unit in most cases. Sometimes there are also 12 volt servos, so they are available with other voltages, but 5 volts is probably 5 and 12 are the most common voltages. I think my linear servos also support up to 12, but the other thing, I think the other one is more like 5 volt. And then yeah, they got like a one signal from the controller. So the controller is connected to ground and to signal, and the power supply unit to 5 volts. And that's how this, or to as a supply voltage. That's how this is usually wired. And there's like a color coding on most servos, like it's black for ground, red is the voltage, and white is the signal. Sometimes the signal is also like yellow, and ground is like brownish or grayish. So, but you will see on my two examples, those are the two common color codings. And now one last thing is like the data format. It's really simple. So we got like the time on the bottom on the x-axis, and on the y-axis we got like the signal level. So 0 volts usually, and 1 for like 3.3 volts or something, depending on the controller, like maybe also 5 volts. That doesn't matter so much. But what you have to understand is that this signal works by sending pulses of like 1 to 2 milliseconds. So if I want to drive the servo to the leftmost position, this controller periodically sends like a pulse of 1 millisecond. That's what's shown here, right? 1 millisecond on, then 19 milliseconds off, 1 millisecond on, 19 milliseconds off. So it's like a 50 hertz signal. That is like the standard frequency, and this will like drive the servo to the left, or to the leftmost position usually. Might be in some cases a little bit less even than 1 millisecond, but roughly 1 millisecond. The specification is 1 to 2 milliseconds. The reality is sometimes different. And also like this 19 millisecond doesn't matter so much. So if that frequency varies, that in my opinion, in my experience, doesn't really matter. It's more important that this pulse length is like accurate. And then if you want to move it to the middle, you make this pulse a little bit longer, so it would be 1.5 milliseconds. So that would move the servo to the middle, and then the pause would be a little bit shorter, obviously. And then you can probably guess it, we can make it even longer to 2 milliseconds, and the pause will be 18 milliseconds, then it will move to the right position. Yeah, that's how this signal basically works. So it's just 1 to 2 milliseconds here, and yeah, sometimes it might be like only 0.8 milliseconds and up to 2.2 depending on the servo. But I will even show you that in configuration because my servos are different. Yeah, and now that's the theoretical part. Now to the demo, like I will show the 2 servo types, and then I will show the 5 controllers I just mentioned. Yeah, and that's basically the theoretical part. And now we will come to the demo. That's the wrong way. Yeah, I will show this view. So what do we got? So first we got like the tower servo, and I mean, yeah, I mean, if you got any questions, just write in the chat. So I mean, from the theoretical part, if anything is unclear, or if it's too, if you want to know anything, let me know. Yeah, so first would be like this tower servo. This is the small one. I mean, it's how it looks. This one is like a 9-gram servo. It's like less than €1. I got like 6 of those for $5. So out of Amazon. So it's I mean, it's a small cheap servo. It does the job for like small toys, but it's not like something to move like large masses or something. So we can turn it. So this is basically the most left position, and now we can move it like a little bit more, and to the other side. So you can also move it around, and you see this one is like roughly 180 degree. So pretty simple. There are also some servos which go like 360 degree, 90 degree. There are different variants. So, but I guess 180, like this one, is the most common one. And yeah, I can repeatedly control it to go to certain locations via MPF here. And one thing which I just added as well is like I can also disable it. So currently, like if it's in this position, I can push it here and it will go back. I mean, it's hard to see. I do not want to break it, but it doesn't matter. It makes noises if I press it, and it pushes back. And it will also, I mean, it will always go to the same location here. So that's like it's repeatable within like a little bit of tolerance, but in general it's a repeatable position. So that's pretty nice. But I can also like disable it. So now I disabled it, and now I can manually push it, and it won't resist. So the controller does not drive it anymore, and that's sometimes usable. So for example, if you detect that the ball is stuck behind the servo, you might want to disable it so it won't overheat, because it won't constantly push against the ball. Yeah, that's the tower servo. And then I got this linear servo here, which is like a little bit more pricey. It has a gearbox here, and it's like a linear servo for like, I don't know what it is, like 10 centimeters or something. We can move it in. So you see that it's not very fast. And we can also move it like all the way out. I think that this would be faster if I connected it to 12 volts. So I'm currently running this on 5 volts, and more voltage is usually just faster. And at some point, I mean, if you give it too much voltage, at some point it just breaks. But usually more voltage is more heat and also more speed. Sorry. So this servo has more features. So this is like, as I told you, it's a little bit more expensive. So this is like the servo connector, the RC connector, and then there's like an additional connector which has a few more features. So this one has, for example, like a feedback line which is connected outside, so that you can put in like an AD converter, like an analog digital converter, which can then read the position back from the servo, which might be useful in some applications. There's also like a PWM mode, where instead of this short pulses from 1 millisecond to 2 milliseconds, it can like evaluate the whole phase. So that would be more accurate. And I think there's also like a voltage controlled mode somewhere here. But I never used that. So I tried the PWM mode, and that definitely works. But yeah, for most applications, this RC mode would be is good enough for this servo. Interestingly, when I tried this disable mode, so this servo cannot be like disabled. So even if I disable the input signal from the controller, it will still push back, and it won't stop for some reason. So this is odd to me, but maybe this controller is simply more intelligent than other controllers, and it just remembers the last position. Yeah, so this is nice if you just want to lift something up or move something out and in. The servo is a nice option. It is also available in stronger and in shorter and longer. And there are a lot of options for this servo on the market. So this is like the 12 volt, 10 centimeter. I don't know what this is. That's probably the power or the gearing or something. So yeah, those are available on the internet. Yeah. So what I got in my setup here is like that's the Pololu Maestro. That's a small controller like for 6 servos here. It has a lot of options, like you can control it like via serial from your Arduino if you want, but with MPF we are controlling it via USB. I feed in like 5 volts here from my power supply unit, and then you just connect the servos and they just work. So that's really awesome hardware in my opinion, and yeah, that just works. Then we got like the Multimorphic PD LED. That's this watt, and that's usually used to drive parallel LEDs, but it can also do like steppers, servos, and also serial LEDs. So with like the version 3 firmware, that started to support a lot of stuff. You can configure this in MPF in like a section of the. I will show you. So you can configure that if you want, like in the PROC section, and there's like the PD LED boards, and now I put like the ID, for example, -8. I give you the ID 8, and now I should be. Does it support here? Selected a dictionary. Okay. Okay, it cannot it cannot autocomplete this, unfortunately, but that's something I probably have to fix. But what can it do? It can do like something like, yeah, it's just use servo 0. Now I can set it to true, and that will enable like those servos. So the support is rather simple, but I mean it will work for like most basic servers. So if you got the board, then this is like really a simple option to add your servos. Unfortunately, you need like hardware like adapters, because you cannot just connect the servo on the board. Yeah, right. You cannot just put the servo connector here. So you need like some adapter board, or I don't know, jumper wires. But like this board can generate the control signal for you. For fast, it works like even a little bit simpler, because it is an add-on board, and you simply configure your servo for the ID of this board, right? This board has the ID and the chain, so they just increment the ID with every board you connect. So the first one is 0, next one 1, and so on. And the servo will have like the same board ID, and then there's like 0 to 5. So that's very simple, and that's how you do it with fast. For like the Raspberry Pi, there's like the Raspberry Pi platform in MPF, and that like works by configuring the Raspberry Pi platform. That's also rather like called Raspberry Pi. Raspberry Pi I, okay, called Raspberry Pi, and basically you just configure the IP of the Raspberry, which could be localhost if you have MPF running locally, and the port, which would be default 8888. and that's it. Afterwards, you can just configure your servos as servo 1, 2, 3. And there's in the documentation it says it's described which pin will be which servo number. So that would be how it works with the Raspberry Pi. And finally, we got this like this PWM controller, and that works like you have to configure it via I2C. So it has a certain address, and that depends on how your controller does it. But in generally, I mean, you can copy it out of the documentation. And yeah, it's just one setting where you set like I2C controller, I think, or servo controller, something, servo controllers, and you set like the I2C ID, and then it's working with MPF. So those are basically my controllers, I think. So yeah, that's all I got. What else do I have? Yeah, I can show you how those two servos are configured and show you a few things there. That works like this. I got like this configuration for the Pololu Maestro, which is a small board. And the Pololu Maestro is basically connected via a serial port. On Linux, for me, that's TTY ACM0. And on Windows, it's usually, I don't know, COM1, COM2, COM3. On Mac, it's also, I think it's a different syntax again. Now there's not a lot to configure, but there's, and you can see the autocorrect here. So you can configure debugging, logging, and the servo min and max position. And this is basically this 1 milliseconds to 2 milliseconds. So this now is 2000 to 9000, which looks odd. And the reason for that is that this value is like in quad steps. So this is basically 2000 divided by 4, so it's 500. It's needed because my tower servo here, to turn totally to the left, it actually needs like half a milliseconds pulse. I just tried it. And for the maximum pulse, that's 9000 divided by 4, that's 2250. So that's basically what I need for the maximum pulse for that, for this particular servo. But it's like a really cheap servo, so if you buy like a better or more expensive servo, that should be more within the 1 to 2 milliseconds. But it's not unusual that it's sometimes a little bit more, a little bit less. For servos, those are basically the two servos. This one is like the tower servo. It's number 0 because it's the most left position on the Maestro. And then I can control it by defining like position events in MPF. So that's like my buttons 1 to 5 on my keyboard, or like the 0 position to the 1 position, like it's a float value from 0 to 1, right? It's from 0% to 100%. And that in this case then turns into like 0 to 180 degrees of the servo. So this will be 90 degrees, 0, and 180. Then there's like the stop event where you actually disable the output on the servo controller if the controller supports it. Not all of them do, but most. And this will, as I showed you, allow me to turn the servo manually, like on like this, right? MPF will also do that when you shut it down. So on shutdown, I mean, if it crashes, it might still, the controller might continue to drive it. But if MPF shuts down cleanly, it will also stop all servos. So they will be turnable after that. So now you can see the servo turning here. And now, yeah, it's not free anymore. Complaints. And then I got like the second servo, which is like my linear servo, and now this one has like, it's even less than 1 to 2 milliseconds. And to limit my controller so that it won't like drive it outside of the bounds, then like the motor will like push against the edge of the case, and that's really bad. So that's something you always want to prevent. If you turn the servo to like the leftmost position and it starts shaking or making noises, then better turn it off and dial the position back a little bit. And that's what I did with the servo. So I got it a min position of 0.29 and the max position of 0.85. And this controller has like a really high resolution, so this is that really doesn't matter that the range is smaller. MPF will simply interpolate those positions here to like the new positions, and you can also see that if I simply push my 7 event, for example. Now it says, well, moving to position 0 and corrected, it's 0.29. So that's basically how MPF interpolated like the limits to the actual position. And I can also do this for like 0.3, then it's corrected to 0.45799. And here you can see like what it actually sends to the controller, and because I checked it, I know that those 2 bytes, those are the position bytes, and we can now take our calculator if we want. And like I want a cool calculator. This one, a scientific calculator. Put it to hex mode, and we can now look at it. Yeah, we can then see what this means. Like this is the hex position, and that's like 22,056 as the raw value, what we sent here. And that should be like, what is it, 2000 something, probably. Yeah, so this is basically how you can translate the position, but that's only specific to this controller. There's also like a control center for the Pololu Maestro where you can check how this, how it internally works and which values to send. So it's really nice. Yeah, and that's basically how the things work, right? You configure your servos here, you configure your controller, you set your controller in the hardware section, and hopefully it magically works. So that's how servos work in MPF. And yeah, if you got any questions, feel free to ask. Otherwise, that's already all what I got here and what I wanted to show. So that's has been like a shorter session. Let's go back to this. Oh. And we can like, yeah, turn servos around a little bit more. And you can actually see the 180, right? It's pretty much 180 degree. And yeah, I mean, if I go into the way here, like, it will basically push me away. So I mean, basically, one of the disadvantages is that you do not know when this servo reached its target, right? And if you have it idle like I do, this is pretty consistent, I would say. But if you block it somehow, this will be like, it will basically just be slower. It eventually should reach the goal if it's possible. I mean, if it's permanently blocked, it won't, but it will at least try. But you don't know, right? That's one of the things to keep in mind here. But in general, like if you use this for like a toy, if I would put like a toy on here, you could turn it around like in America, the Ghost in America's Most Haunted, for example. That would be something which is nice with the servo, right? And I know that, for example, Stern also has like servo control in Spike, and maybe they used it on some toppers. I'm not entirely sure, but at least I haven't seen it in games yet. But it might be coming at some point. They at least got hardware control for it. Maybe I know they got maybe the Ghost in Ghostbusters. I'm not sure. Does that might be a servo? Not sure. If you know, let me know. But yeah, I do not have any Stern boards at the moment, fortunately. Otherwise, I would show you those as well. The spooky boards got it as well. Like the Pinot Tower board has it, and they have that like I think 4 servo slots. And yeah, there's probably a lot of hardware out there. If you got something else, we can definitely also add that to MPF. And yeah, that's all I wanted to say. So thanks for joining, guys. Hope you enjoyed the stream. Have a great remaining weekend, and I hope to speak to you soon. Keep up the pinball. Keep hacking, guys. I'm out.